Okay, so today we are starting 5.1/5.2, which is verifying trig identities. We're going to spend quite a few days on this. So this is the first day where basically you learn all of your formulas. Okay, so start. Here's our warm-up. So it says all right triangles have two acute angles. Find the measure of the missing angle below. So go ahead and do those first three problems. You can pause this and fill them out. All right, so you should have gotten that x is 50 here. So I'm just going to put 50 degrees here for x. Y here is 54 degrees. And z here is 77 degrees. Okay, so now if we were in class, I'd say, how did you get that? Now, someone always raise their hand. The first person to raise their hand, they'll come back to this one and they'll say, this is 90. This is 40, 90 plus 40 is 130, and then 180 minus 130 is 50 because all triangles add to 180. But there's actually a faster way, and then someone will say like, no, I did it this way instead once I say that there's a faster way. If we know this is 90 in all three of these, we could already do the 180 minus 90, so we know that these two have to add to 90, right? So the two acute angles have to add to 90. So a faster way is doing 90 minus the angle. All right, so 90 degrees minus the angle is the faster way of doing it. Next it says what can be said about the two acute angles. Those two acute angles always add to 90. So there's a word that means adds to 90 if you remember from integrated. That word is complementary. So we're going to say they are complementary. It's good to review that word for many reasons. First off, if you saw it in the SAT or ACT. Also, because of what we're going to talk about next. So once again, that means adds to 90. Okay, so next we're going to look at this triangle right here. Okay, so it has three angles, A, B, C, and then three sides, lowercase a, B, and C. Notice that side A is across from angle A, side B is across from angle B, and so on and so forth. Okay. So the first thing they want us to find here is the sine of angle B. Okay, so I'm going to go ahead and put a little dot in angle B so that my eyes are drawn to it, because if you notice, these are all about angle B here. Okay, so I want the sine, which is the opposite side. This is the opposite side over the hypotenuse. So that's B over C. Then I want the cosine. That's the adjacent side. This is the adjacent side over the hypotenuse. That's A over C. Tangent's opposite over adjacent, so that's B over A. And then I have cosecant, secant, cotangent, and cotangent. Cosecant, secant, and cotangent, which are all, remember, just the reciprocals of sine, cosine, and tangent. So sine and cosecant are reciprocals, so I'm just going to say this is C over B. Secant's reciprocal of cosine, C over A. And cotangent is the reciprocal of tangent, so I'm going to say that's A over B. Okay? Okay, so now notice what I want you to fill out is that, what is that for angle A then? So if I said I wanted you to look at angle A instead of looking at angle B, what is B over C? Is it opposite over adjacent, adjacent over hypotenuse, opposite over hypotenuse? Which one is it? Okay, so what I'm going to do now is I'm going to erase this so that I'm not looking at it. I'm going to change the color here, and I'm going to say I'm looking at angle A now. So if you look at angle A, this is opposite. This is adjacent. This is still the hypotenuse, right? Okay. So if I want to see what B over C is, B is the adjacent side. C is the hypotenuse. So it's adjacent over hypotenuse. So that's cosine of angle A. A over C. So A is the opposite side over C, which is the hypotenuse. So that's the same thing as the sine of angle A. B over A. B is right here. A is right here. That's adjacent over opposite. Adjacent over opposite is cotangent. Next we have C over B. So C over B. So that's hypotenuse over adjacent. Hypotenuse over adjacent is the reciprocal of cosine, which is secant. So this is secant. So now that's where I pause and I say, okay, do you think you can fill out the rest of these without doing that step every single time? And people like look for a pattern. And they're like, okay, this is sine, cosine, cosine, sine. Tangent, cotangent, cosecant, secant. Secant, this has got to be cosecant. Cotangent, this has got to be tangent. And that is going to end up being correct. Okay? All right, let me erase this off the triangle. So what do we notice from this triangle below and these things here? So we did notice a pattern. So obviously there's something that we can reflect on here. The cofunctions of complementary angles are equal. So what does that mean? Okay, so what I want you to realize is that sine, let me get a highlighter out here. Sine and cosine are cofunctions. Okay? The cofunctions of complementary angles are equal. So what I also want you to notice is that if I knew this angle here was 30 degrees, then this would have to be 60, right? So if I filled in 30 here, 30, 30, 30, 60, 60, what this is saying is that the sine of 30 degrees is the same thing as the cosine of 60 degrees. And the cosine of 30 degrees is the same thing as the sine of 60 degrees. And that should make sense. Because if you think about it, the sine of 30 degrees is 1/2, and the cosine of 60 degrees is 1/2. The cosine of 30 degrees is root 3 over 2, and the sine of 30 degrees is root 3 over 2. So this is true. We already actually knew that, but maybe just didn't put 2 and 2 together. So what does that bring us to? It brings us to these 6 rules here, okay? These are 6 formulas that you need to know, but if you look at them, they're quite easy to see. They're quite easy to like see that if you know 3 of them, you know all 6 of them. So this one says is that sine of an angle is equal to the cosine of its complement. That's how you say it out loud. The sine of an angle is equal to the cosine of the complement. Okay, that's how I'm going to say it out loud, just so that you realize that. Sine of an angle is equal to the cosine of the complement. So what I want you to realize that all that this means is that if I give you the sine of 30 degrees and you just forgot what it is, that's going to be the same as the cosine of 90 minus 30 degrees, which is 60 degrees. These two have the same answer. That's what it means. Okay? So if you look at the other ones, it's the cosine of an angle is equal to the sine of the complement. And then tangent and cotangent are cofunctions, and secant and cosecant. Okay, so sine and cosine. It's not sine and cosecant, which are reciprocals. It's sine and cosine, secant and cosecant, and then tangent and cotangent, which are reciprocals. Okay, so this also applies to radians, and then remember, 90 degrees is pi over 2 radians. Just recall that. Okay, so let's say you were doing a problem and secant of 50 was in it and it wasn't helping you. I'm not saying that you don't know what it is because I don't know that's cosecant of 50 is. So what the question is what can I replace it with that might be helpful? So all I have to do is say, okay, its cofunction is secant, and then 90 minus 50 is 40 degrees. So these two things are equivalent. What if I saw a tangent of 4 degrees in a problem and it wasn't helping me and I needed to change it out? Well, its cofunction is cotangent, and then 90 minus 4 is 86. Next one, cosine of pi over 3. I left this all blank for you, so its cofunction is sine. And then some people think in their head, like, oh, I got to change this 2 degrees so I can think. This is 60 degrees, so this would be 30 degrees, and that's pi over 6. But it should make sense. Pi over 6 and pi over 3 makes pi over 2, right? And if you put 30 degrees, you wouldn't get any points taken off because it's still true. Okay. So this right here, let me get rid of, what was that? Let me get rid of my highlight here for just a second, and I'm actually going to change it to yellow. So these are, I guess you could call them formulas, but they're not really formulas. I would just say that they are things that you need to know, right? Like equivalencies, that's what I'll call them, equivalencies. These are equivalencies you need to know. And then we're going to also fill out the reciprocal identities and the quotient identities, which are also things that you need to know, okay? And this I'm going to highlight, so that I highlighted the whole box. This one I'm not going to highlight everything because I'm going to highlight the most popular, okay? All right, so reciprocal, we know what that means, right? Okay. So if I wanted to take the reciprocal of sine, I I know the reciprocal of sine. I can do that is equivalent to 1 over cosecant of theta. All right, because it's equivalent to the reciprocal. The reciprocal is 1 over cosecant of theta. So they are interchangeable. Okay, they are interchangeable. So, and if I wanted to prove this to you, I could say, okay, sine over 1, and then figure it out for you, but just remember it's equivalent to the reciprocal. Okay, so that is cosecant would be 1 over sine of theta. Cosine is equivalent, through using the reciprocal identity, to 1 over secant of theta. Secant is 1 over cosine, right? It's the reciprocal. So doesn't that make sense? The reciprocal of secant is cosine. Yeah. Okay, good. All right, tangent, 1 over cotangent. And cotangent, 1 over tangent. These are equivalent. Okay, so now what I'm going to do is I'm going to use that yellow highlighter to highlight the most common ones we use. Okay? So when I see sine in a problem, usually I'm going to leave it. I leave sines and cosines alone because they're usually going to help me. But cosecant, usually I want to get rid of. I usually am going to want to change it to 1 over sine. So this is a very popular thing. Cosine, if I see it, I usually leave it. I usually don't touch it unless I'm like stuck. Secant, if I ever see it, I change it to 1 over cosine. That's an equivalency. That's very important to know. Secant 1 over cosine, cosecant 1 over sine. All right, the other 4, I don't really use that much. Have I used them before? Yes. Have I seen people use them before? Yes, but I try to stay away from them. Okay, but the other 2 are really important. All right, next, my quotient identities. These you already know. If I said, how can I relate tangent to the unit circle, hopefully you would say y over x, right? But instead of saying y over x, y is equivalent to sine, x is equal to cosine. So remember, recall, tangent is sine over cosine. And that would make cotangent cosine over sine. And we already learned both of these. I'm going to highlight these also because these are used a lot. Now, if I see tangent and it's not helping me in a problem, I will change it to sine over cosine. Notice that you could also change tangent to 1 over cotangent, but to be completely honest with you, I have never ever done that in a problem that I can think of. Okay? Okay. So, what I want to do next is, before I move on to example 2, I want to go ahead and try some problems using this right here. Okay? So I'm going to try some problems using the cofunctions. Okay? That means we have to zip down to example 3 in the notes. So I'm going to zip down to example 3 right here. Okay? It says, given that the sine of theta is 1/3, find. And then notice what I'm asking you right here. I'm asking you for cosine of pi over 2 minus theta, which is the complement, cosine of the complement. Okay? Now, I know that sine of theta, if I go back up here, sine of theta is the same thing as cosine, right here, is the same as the cosine of 90 minus theta. So I'm asking you right here, what's the cosine of 90 minus theta, or pi over 2 minus theta? It's the exact same thing as sine. So I'm going to put 1/3. Okay? So knowing that the sine is equal to, sine of theta, is equal to the cosine of 90 minus theta is very helpful here because you know that they have the same exact answer. Now we're going to skip b for a second. We're going to come back to it. Next, I want cosecant of theta. If I gave you sine, we know cosecant's the reciprocal. 3 over 1 is just 3. Next, notice this says the secant of the complement. If I know that cosecant of theta is the same thing as the secant of 90 minus, 90 minus theta, I know that those two have the same answer. This is 3. Okay? All right, we're going to have to come back to do b. That's why I skipped it. I know it seems weird to have gone and done that, but hey, I felt like it. All right, next what we're going to do is we're going to do example 2. We're going to simplify each of these. And it's nice to like leave and come back. Now, once again, these 4 that I have highlighted are the most important. You might find yourself looking back at them right now, but it's not that hard to memorize these 4 things because you actually already know all of them. Cosecant is the same thing as 1 over sine. Secant's the same thing as 1 over cosine. Tangent, sine over cosine. Cotangent's cosine over sine. Okay? All right, so what we're going to do is we're going to come here and it says simplify each of these expressions. So these are all simplifiable. So I'm going to ask myself, what can I replace cotangent with? okay? I can replace cotangent with cosine of theta over sine of theta. I have times. Next, I have secant of theta. What can I replace secant of theta with? 1 over cosine of theta. And now I want to simplify this. Remember, this is a fractions that are being multiplied that you're simplifying. The question I always get in class is, do I cross multiply? Someone asked this first semester in one of my classes. The answer to that is you only cross multiply equations. None of these are equations, okay? So you're never going to end up cross multiplying in any of this. What you're doing is you're simplifying. So you're looking to see if there's anything you can simplify. This is all one big fraction here now once you multiply. So anything in the numerator will cancel with anything in the denominator that's a factor of. Cosine and cosine will cancel. So now I have 1 over sine. And this can be simplified a little bit more. 1 over sine, what can I replace that with? If you look over here, it's right here. It is cosecant of theta. Okay, so notice what it simplified to. You might be saying to yourself, doesn't look that much better. Looks a lot better to me. All right, next I have sine of 17 degrees and cosecant of 17 degrees. When these are the exact same, it doesn't matter what they are. They could be theta, they can be 20, they can be 17. If they're the same, I don't worry about it. I just leave the way it is. Okay, sine of 17 degrees. Remember, I leave any sines and cosines because I'm hoping that they can just stay the way they are. Times. Cosecant, I'm going to replace. What can I replace cosecant with? I can replace it with its reciprocal, which is 1 over sine of 17 degrees. Now I need to simplify this. Now, whenever I have sines and cosines, I usually end up just putting them over 1 anyways, just because I wanted to look everything balanced, and making everything a fraction just helps me. All right, so I see I have a sine of 17 in the numerator, sine of 17 in the denominator. That simplifies to 1, right? They cancel each other out. And then I have 1 times 1, which is 1, over 1 times 1, which is 1. So this simplifies to 1. All right, next one, I have sine of 40 over cosine of 50. So the first thing I notice right here is that these aren't the same, right? And I want them to be the same so I can simplify this. The only way I can simplify it is if all the angles are the same angle, okay? So I say, well, what do I notice about 40 and 50? 40 plus 50 is 90. So I say, wait a minute, these are complementary. So what I'm going to do is I'm going to pick one to keep. You just have to pick one to keep. I'm going to keep the 40. So I'm going to keep sine of 40, and I'm going to leave it exactly the way it is. But I want to change this to 40 degrees also. Okay, I want to change that to 40 degrees also. So if I'm going to change the angle from 50 to 40, I have to change this to the complement. The complement of cosine is sine. So now I look at this, and how can I simplify sine of 40 over sine of 40? Anything divided by itself is 1. Okay, next one. First thing I notice is all 3 angles are exactly the same. 71, 71, 71. So this is good to go. I'm going to start by looking at secant and saying, should I keep it or should I change it? Since it's secant, I'm going to change it. 1 over cosine of 71 degrees times. Since this is sine, I'm going to keep it. So I'm going to put sine of 71 degrees over 1 minus. Tangent, I like to change. I'm going to change that to sine over cosine. So sine of 71 over cosine of 71. Now this is not the only way to do this. I'll show you another way in just a second. All right, so now I'm going to look to see how I can simplify. So here, this right here is multiplication. So notice I don't even have the subtraction on my screen yet. And I say, can I simplify anything? No, nothing cancels out. But what I can do is I can make it one fraction by multiplying straight across, right? So I'm going to change this to sine of 71 over cosine of 71. And then I have minus, and I notice that this is the exact same thing, sine of 71 over cosine of 71. So anything minus itself is 0. Okay? Another way of doing this problem here is that I'm going to erase this really quickly. Okay? Another way of doing this was starting it off. Actually, I shouldn't have erased the whole thing. So I'm going to erase this, and if I never changed this, if I left this as tangent of 71 right here, I could have at this point said this is tangent of 71. And then done tangent minus tangent is 0. Okay, last one in this section here. First thing I say to myself is, can I just get started? The answer is no, because the angles are different. So I have 49-degree angles and 41-degree angles. But what do I notice about 49 and 41? I notice that they are complementary. So what I want to do is I want to pick an angle to keep and then get rid of the rest, or not get rid of, but change the rest. So what should I keep? I would keep 41 because there's more. So I'm going to get rid of all the 49. So what I like to do is lightly cross them off to know that like they're not going to stay and I need to change them. So I need to change this to 41 degrees and I need to change this to 41 degrees. So I need to change it to their complements. The complement of cosine is sine. The complement of cosecant is secant. And notice I'm not saying reciprocal, I'm saying complement. So make sure you don't confuse reciprocal and complement. All right, now I'm going to go through and treat it just like the ones that I have done in the past. So the first one, sine of 41, I leave sines alone, I leave cosines alone, but I do like to put them over 1 times, because this is multiplication and multiplication here. Secant, I'm going to change to 1 over cosine of 41. Cotangent, I'm going to change to cosine over sine. And I have this minus here. I'm going to actually put the minus in a different color. So you realize that you can't touch anything on this side unless it's with something else on this side. And I'll put this in blue here. Cosine I'll leave. Cosine of 41. I'll put it over 1 though. Times, and then this is secant, which I'll change to 1 over cosine of 41. Okay, so I'll look at the orange first because I can't cross off anything with the orange and blue from numerator to denominator because they're separated by subtraction. So look at this orange side first, and I'll say, okay, is there anything I can simplify? We'll have a cosine of 41 over a cosine of 41. Those cancel, right? I have a sine of 41 over a sine of 41. Those cancel. So I have 1 times 1 times 1 over 1 times 1 times 1. This simplifies to 1. Then I have the minus sign. Then I'll come over here and I have a cosine of 41 over cosine of 41. Those cancel to 1. 1 times 1 is 1. So I have 1 minus 1, which is 0. Right? Okay, so before we try more, because if you look at the end here, we're going to do a few more. What I want to do is I want to go through our fundamental identities. So these identities are super important. You use them in calculus all the time. And they're identities that we want you to recall, have in your head, just like you know Pythagorean theorem, okay? All right, so speaking of Pythagorean theorem, this one comes from the Pythagorean theorem. So remember, if I said do the Pythagorean theorem on this, because it's a right triangle, you would do side squared plus side squared equals hypotenuse squared. So a squared plus b squared equals c squared, right? So I'm going to do side squared. So side, which is sine squared. I already put the squared there for you. Plus side, which is cosine squared, equals hypotenuse, which is 1 squared, technically. Okay, so that's our first identity. We actually clean it up, though, because we don't put the parentheses in the square. Another way of writing sine of theta squared is you can write it like this, sine squared of theta. And then we have plus cosine squared of theta is equal to 1. So this is our most common identity. It's identity number 1. We use it the most. You see it the most. It's the one that's the easiest to recall. Sine squared plus cosine squared equals 1. So this, once again, notice it's one of the things that I have highlighted that is used a lot. So these are used. I highlighted this whole thing because if you know one, you know all of them. And then these 4 are used a lot. And then this is used an extreme amount of times also. Okay, our next identity, which is used a lot also. How we're going to get it, we're going to actually come up with it. Instead of me just saying like, here it is, I'm going to show you how to get it. Okay, so it says if cosine of theta is not 0, we can divide the first identity by cosine squared and we'll get our next identity. So I'm going to start by writing out our first identity. Sine squared plus cosine squared equals 1. And it's of theta, and you have to have the theta part. I just don't say it out loud. Okay? All right, so it said divide everything by cosine squared to get your next identity. So we're going to divide by cosine squared. Divide by cosine squared. Divide by cosine squared. Okay. Now, obviously, this is simplifiable. What can I change? What can I change sine squared over cosine squared to? What can I change that to? And if you're like, I don't know. What can I change sine over cosine to? Tangent. Now it's squared, so make sure you're changing it to tangent squared of theta. Plus, what can I change cosine squared over cosine squared to? Anything over itself is 1 equals. And then what can I change 1 over cosine to? 1 over cosine is the same thing as secant, but this is squared, so secant squared of theta. This is our second identity. Tangent squared of theta plus 1 equals secant squared of theta. This is our second identity. I'll try to give you a way to memorize these in just a moment. Okay? All right, so the very last one we get by taking the original, sine squared of theta plus cosine squared of theta equals 1. And now we're going to divide by sine squared. Divide everything by sine squared of theta. Okay, what can I change these to? So sine squared over sine squared is 1 plus. What about cosine over sine? I can change that to cotangent squared of theta equals, and 1 over sine squared I can change to cosecant squared of theta. So I have 1 plus cotangent squared of theta equals cosecant squared of theta. Okay, so this is my third identity. Now, these 3 identities I have highlighted because they're very important and used a lot. So I'm going to give you hopefully a way to help you memorize them. First one, you have to memorize it. That's what I'm going to tell you. Sine squared plus cosine squared equals 1. The second one I came up with a story for. Okay, I used to live in townhouses, and I lived with my husband there, and we used to have a pool. Now, my husband, he's crazy. He likes to go swimming, right? So like when he goes swimming, he's always in the pool and he's like, Jill, get in the pool, come on, get in the pool. And I used to always have to say to him, Phil, stop it. Let me tan for 1 second. And that's how I remember this one. Tan for 1 second. Tan for 1 second. Now, if you notice here, I have sine, cosine 1, tangent 1, secant, and then the other one's 1 cotangent, cosecant, so what's left over? That's how I remember it. But someone last year in my class, his name is Angelo, he came up with this to help remember this one. I giggle because I don't see it. He says, I want 1 coat, and then he called this Christmas. I don't know how, I don't know why. If it helps you, hey, why not? 1 coat for Christmas. So tan for 1 second, 1 coat for Christmas. Maybe that'll help you. Maybe it won't. Okay, so the only part we didn't find in B here is cosine squared. Now, remember we just learned that sine squared of theta plus cosine squared of theta is equal to 1. And we want to solve for cosine squared, so I'm going to highlight it right here. We want to solve for that. So I need to say, well, what's sine squared? This is sine. And then I have plus cosine squared of theta equals 1. So I can solve this. 1/3 squared is 1/9 plus cosine squared of theta equals 1. And then remember, I'm trying to get cosine squared of theta by itself. That's what I'm solving for. So subtract 1/9 from both sides. And I have cosine squared of theta is equal to 1 minus 1/9 is 8/9. So the answer is 8/9. Now people are like, wait, do you have to square root? It said find cosine squared of theta, right? Okay, what we're going to do next is we are going to move on to these here. Now, I want you to realize this. This set of notes is just what can I replace it with, what can I bring it down to, and people always get panicky and they're like, how do you know when you're done? How do I know when to stop? How do I know this is not good enough? Here's what you can realize, okay? On your test, it's already going to tell you what it's equivalent to, and you just have to get it to that point. So your steps are way more important than your answer. I want you to realize that. Okay, so it says simplify each. So basically I'm looking for what can I replace it with and then simplify it down, okay? So 1 minus cosine squared. So a little trick hint that I want you to know when you see this is that whenever you see something with a 1 and then something else squared, because 1's a number squared, right? So if you see two things squared, like secant squared and tangent squared, or 1 and cosine squared, or cotangent squared and cosecant squared, that's always going to be replaceable with, not always, but most of the time it's going to be replaceable with one of your trig identities. So the first thing I'm going to practice by doing right here, and it might seem silly since those are right above, is I'm going to write my 3 trig identities right here. Okay, and it's good for practice for memory too. So the first one, sine squared of theta plus cosine squared of theta equals 1. Tan for 1 second. Tangent squared plus 1 equals secant squared. 1 coat for Christmas. 1 plus cotangent squared equals cosecant squared. All right, so those are my 3 trig identities. So I look and I see this one has a 1 and a cosine squared. Which one has, and we're going to call this 1, 2, and 3, because that's their numbers, right? Which one has a 1 and a cosine squared? Number 1 does. But I don't want it to be sine squared plus cosine squared equals 1. I want it to be 1 minus cosine squared. So if I had to manipulate this first identity to get it to be 1 minus cosine squared, right, I would have to subtract cosine squared from both sides. What would be left on the other side? Sine squared. So this is equivalent to sine squared of theta. What about this next one? Which one has secant squared and tangent squared? Number 2 does. But I want it to be secant squared minus tangent squared. Okay? So if I want this to be, let me change colors here. If I want this to be secant squared minus tangent squared, I would have to subtract secant squared from both sides, right? So this would come over here to be minus secant squared. This would be gone. But this 1 would be over here. So I'd have to get it on this side and I have to subtract 1 from both sides. So it's equivalent to -1. It's easier to show this in person clearly. Okay, what about cotangent squared minus cosecant squared? So obviously you're using the third identity. I want it to be cotangent minus cosecant squared. So I would have to get this on this side by subtracting it, but then I'd have to get this on the other side by subtracting it. So it's equivalent to -1 also. All right. Oh, I did this. This one I read wrong. It's secant squared minus tangent squared. So this one's not even right. My bad. This one was secant. I did tangent squared minus secant squared. Secant squared minus tangent squared. I'd have to subtract tangent squared from both sides to get on that side, and there'd be 1 left on this side. There we go. I read it wrong. Okay, so let me get rid of all these arrows here. I wouldn't have caught that, but I just let me look at it and double check and realize I read it out wrong. Okay, so first off, I see they're both 2 different angles here. I see a 35 and a 55, and I can't work with that unless they're the same. On the 3 above, they were all theta, so they were all the same angle. These are not the same angle. So remember what I have to do. I have to keep 1, get rid of 1. They're complementary, so I can do this. So I'm going to say you're not going to stay here. I'm going to change you to a 35-degree angle. Okay? So I say, what's the complement of sine, which is cosine, but don't forget that it's a squared. So now I have sine squared of theta, or 35, I should say, plus cosine squared of theta. Oops, I did theta again, 35. But I want you to realize that it doesn't matter what angle this is. It's the same angle, so it's theta. Okay, so it doesn't matter that it's 35 and 35. It's just the same angle. Sine squared plus cosine squared is 1. So this is equivalent to 1. I'm going to get rid of those thetas that I drew over it. Okay, so now they're going to get a little bit more difficult here. Next, we have cosine squared times cosecant squared minus cosecant squared. So I have to think about what I can do, what I can change. Okay? So I say to myself, I can change cosecant squared to 1 over sine, but I still get stuck. Okay, I still get stuck. So I could actually change to 1 over sine, then change that to cotangent, but then I have a cotangent and a cosecant, and I can get here probably. So that might be helpful. That's one way of doing it. Okay? Another way of doing it is to say I can factor out a cosecant squared. I think it's easier to say I'm going to change this to 1 over sine squared. So I have cosine squared of theta. And if you do something and nothing good comes from it, then start over, try something else. Cosecant squared I can change to 1 over sine squared. And then I have minus, and I'm going to leave this as cosecant squared for right now until I can see what I can do with this side. All right, so this, nothing cancels, but I have a cosine over sine. Cosine over sine is the same thing as cotangent squared. And now I see two things squared, and I'm like, okay, this was three things. That was a little like, ooh. So I have cotangent squared minus cosecant squared, and I say, ooh, that looks like my third identity, but not exactly like it. I need it to be cotangent squared minus cosecant squared. So I would have to subtract this onto this side, but then I have to get this onto this side, so it's -1. So if you look, I got it to look like this right here, right? Now, if you look at my notes, I have this a completely different way. There's another way of doing this. So the way I did it in my notes is I say, oh, they have a cosecant in common. I'm going to factor it out. So I factored out the cosecant, and then I was left with cosine squared of theta minus 1. And then I was said, okay, cosecant squared of theta, and then what can I change cosine squared minus 1 to? So I said, okay, cosine squared minus 1. So I subtract 1 from both sides, get this on the other side. That's negative sine squared of theta. And then I said I can change this to 1 over sine squared times negative sine squared over 1. Those canceled, and I was left with -1. I like this way, the first way that I did it better. Okay, next one. So first thing I want you to notice is that people see this and they're like, ooh, the first identity, because there's a sign and a 1. Remember, it has to be squared. So I would say to you, well, what can you do with this? Like, use basic algebra. And then someone will shout out, FOIL. Absolutely, you can FOIL this. So let's see what happens when I FOIL this. I'm going to do first times first. Sine times sine is sine squared. Outer. Sine times -1 is minus sine. All right, inner, 1 times sine is plus sine. And 1 times -1 is minus 1. Okay, so now I'm going to look to see what I can do to clean this up. I have a minus sign and a plus sign, so that's out. And now I have sine squared of theta minus 1. So I say, okay, what can I do with this? This is two things squared, a sine squared and a 1 squared. So I say, okay, what trig identity does that look like? That looks like my first identity, but I need to be sine squared minus 1. So I need to get this, subtract 1 from both sides, and then this I have to subtract from both sides. So that's the same thing as negative cosine squared of theta. Okay, next one. So first thing I say is that I do see, this is a 1 squared, this is a cosine squared. This is a 1 squared, this is a cotangent squared. So I do see squares. So I'm going to look at my identities. I need to know what I can change 1 minus cosine squared to. All right, 1 minus cosine squared. So 1, I need to get rid of all these arrows on here. Okay, I need to be 1 minus cosine squared. So I need to subtract cosine squared from both sides. This would be left on the other side, so this is equivalent to sine squared. What about 1 plus cotangent squared? I need to be 1 plus cotangent. That's this right here. That's equivalent to cosecant squared. So this is times cosecant squared. And I say, okay, sine squared I'm going to leave alone. So I'll do sine. And some people will be like, okay, what identity now? This is multiplication, not addition. So I'm out of my identities. Sine squared, I'll put it over 1 times, what can I replace cosecant squared with? 1 over sine squared. Sine squared over sine squared is 1. 1 times 1 is 1. Okay, now, when I assign this homework, there's always someone in class who will just go through everything and put 1 or -1 down. The work is what matters more. This is worth nothing unless you have this. Okay, just so we realize, from here to here, that's 1 step. You'll not see anything on your test that's 1 step. It will be where it's multiple steps to get there, and I'll already tell you this is equal to 1. You have to show me these steps, okay? All right, the very last one here, okay? So first thing I notice is that this is not squared, so I have to do something about this. This is not squared, so I have to do something about this. So let's do something about it. All right, so what can I do if I saw x plus 2 quantity squared and I was like, I need to do something with this, I could expand it by writing it out by it times itself. So that's what I'm going to do. Sine of theta plus cosine of theta times sine of theta plus cosine of theta. Then I'm going to change the color here, this plus sign right here. And then I'm going to change the color again. And then this is going to be sine of theta minus cosine of theta times sine of theta minus cosine of theta. And now I'm going to expand this by doing the FOIL method, which is just the distributive property. All right, so I'm going to multiply this out. Sine times sine is sine squared. Sine times cosine is sine cosine. But if you look at inner here, I have another sine cosine. So I have a sine cosine and a sine cosine. There's 2 of them. You could write it out and then combine like terms. I'm going to combine like terms in my head and say plus 2 sine cosine. And then last times last, cosine times cosine is cosine squared. I have plus. And notice I didn't change the color this time because now it's addition, all addition, and there will be subtraction in here. But I don't have to worry about, you know, accidentally moving from one to the other. All right, next, sine times sine is sine squared. Sine times negative cosine is negative sine cosine, but also notice that inner is negative sine cosine, so I have 2 of them. So I have negative 2 sine of theta cosine of thetas. And then last times last, I have negative cosine of theta times negative cosine of theta, which is plus cosine squared of theta. All right, now I'm going to look to see how I can clean this up. Okay, I'm going to look to see how I can clean this up. So first thing I notice, let me get a different color here, red, is that I have a 2 sine cosine and a negative 2 sine cosine. So I know those cancel out. They're gone. Okay, so now there's 2 ways of looking at this. You can see it is, I have a sine squared and a sine squared, so I have 2 sine squareds. I have a cosine squared and a cosine squared, so I have 2 cosine squareds. Then you can say I can factor the 2 out. And this is 1, so 2 times 1 is 2. That's one way of doing it. Or you can look at it even faster way. I have a sine squared plus cosine squared, which is 1 plus. And then I have a sine squared plus cosine squared, which is 1. 1 plus 1 is 2. I like that way better. Okay, that's it for notes for today. I know they were long, but the next lesson is just practice.